All right, guys, thanks for joining us. I think this is the closest to 1 o'clock we've been able to start this thing, so I'm proud of myself for that at least. We are going to get started here, make sure I've got the right clicker, and you can see I've already, from a few of our science experiments, have a few issues going on. Let's see. Let me try the other one. This one has been acting just a little bit funny. This is the clicker we use when we're on air to try and get through our show. Here's Samantha McCollum. Samantha.
Hi, welcome.
And Brett behind the camera. There we go. I guess we just have a dead battery in this one. So we were talking, thank you very much, winter weather for today. And there are a lot of topics when it comes to winter weather that we're not going to get to touch on. But the biggest one is going to be snow and then the different types of wintry precipitation. We're going to ultimately try to make our own snow with probably some stuff you have around the house. We're going to use this big bowl, a lot of baking soda, and then a couple other ingredients. We're also going to try and make a snowstorm. This is going to be the first time I've tried this one, but a snowstorm in a jar or in a vase is something else you can try. Let's start off here with a little bit of the background. So we've got winter weather. Of course, snow is the thing that most people think of. And one of the number one rules for snow or any sort of wintry weather is temperatures have to be below freezing. So, or the freezing point of water, to be more specific. So we call that 32 degrees Fahrenheit or 0 degrees Celsius. And that's the temperature where water freezes. Now that's important that it doesn't have to be the entire atmosphere. It doesn't necessarily have to be freezing down here on the ground to get snow, but in order for snow to fall and for snow to stick, it's got to be freezing from way up in the clouds all the way down to the ground. And that is where we end up with different types of winter weather, whether it's sleet, freezing, rain, snow, that all has to deal with the temperature throughout the entire atmosphere. So if you think about it, down here on the ground, let's pretend, try and get something that would be a little bit closer to scale. But let's say this is your house, it's only this tall, but the clouds are way up here closer to the ceiling. So you've got to have freezing temperatures in the air from way up in the clouds all the way down to your house and down where you live on the ground. So what happens when we have those different temperatures? We're going to take a look here at some of the different types of winter weather that show up that we talk about. And there's 4 main ones, and sometimes during the winter it rains. So I know we don't typically think of that as a winter type, but here's what's going on. So here are our clouds way up top, down toward the bottom. You can see here in our little picture we've got some trees, houses, barns. So when we end up with rainy weather, that might be freezing up in the clouds, but there's a lot of warm air down here at the surface and pretty much right below the clouds. So anything that falls out of the cloud, even if it's snow, a snowflake, or a raindrop, it is going to melt and then stay rain all the way down to the ground. One of the worst types of winter weather that we can see around the country is going to be the next one, and that's going to be freezing rain. That happens when we've got a lot of warm air basically from the clouds down to right around ground level. But down here, close to where we are, there's basically this pocket. There's this little layer of freezing air where the air is either 32 degrees or colder. So what happens, those snowflakes or raindrops that fall out of the cloud, they melt, then they fall down all the way to the ground as raindrops, as liquid, completely still liquid. When it hits the ground, it looks like it's just rain, but then it starts to freeze over, and it freezes on everything. Freezes on power lines, freezes on your car, freezes on the street, and that's how we end up with more or less like an ice skating rink. So again, when we say freezing rain, it looks like rain all the way down. It'll even splash off the ground sometimes, but then that's when it turns to ice. And that's when we have warm air from the clouds down to, really it doesn't have to be too much, maybe a few hundred feet above the ground, and then that's where we have this little layer of cold air. Then we switch over here, we'll go one more. This is a little bit more cold air. Now usually what we end up with here is kind of a skinny layer right in the middle where we do have this warm section, but for the sake of this picture, it's warm right at the very top. So what we have here, cloud, the snowflakes, the raindrops, they fall out of it, they melt briefly, but then on their way down, while they're still in the air, they refreeze. They freeze into little ice pellets, and that's what we call sleet. So the big difference, and one of the more confusing ones, is freezing rain versus sleet. So when you think of freezing rain, just remember, it looks like rain when it hits the ground. It's still liquid when it shows up for us. Sleet, on the other hand, is going to be a little tiny ice pellet. And one of the best ways to remember it is you can remember sleet has a beat. When you see and hear sleet, you actually, well, that's the thing, you'll hear sleet. It'll ping off of everything that it hits, and that's because it's little pieces of ice falling down from those clouds. That's very different from hail. When we talk about hail, it's still ice pellets or ice balls, but those form in thunderstorms where this forms on the way down. It melts and then it refreezes. And last for us, we've got snow. And that's when the air is colder than, or at least 32 degrees from the cloud all the way down to the ground. So it leaves the cloud as a snowflake, and then it never melts, doesn't change. It just floats all the way down to the ground as a snowflake. Fun little fact for you, depending on what the winds are like and depending on how big the snowflakes are and really how high the clouds are, it can take about an hour for some snowflakes to come all the way down to the ground. That's only going to be on a windy day where it kind of takes a little bit of a crazy path down to the ground, but that just kind of goes to show you it's a long way down from those clouds for something so light trying to move through. So those are our big main types that we talk about: rain, freezing rain, sleet, and snow. And part of our job as forecasters, as meteorologists, is to figure out how it's going to play out. And you can see here that based on this, it doesn't take very much. A little difference in a layer of warm air or cold air, you can end up with very different weather showing up where you live. And it will change sometimes throughout a winter storm. It might start as rain, go to freezing rain, and then back to sleet and snow, back and forth. So freezing rain, here's a really nice picture, kind of pretty picture, but this kind of picture can do a lot of damage, is when that rain falls down, it lands on things like the pavement or trees or branches in this case, and it kind of encases everything in ice. So it lands as water and then freezes pretty quickly on contact, and that's how we end up with things like this. And while this looks pretty, this adds a ton of weight to the trees. And next thing you know, large branches come down, sometimes trees come down, and that's what brings out power lines. So that's one of the big things. I know Samantha did a story earlier this year on an anniversary of a big ice storm that happened in South Carolina, and tons of people without power. And it takes a long time to clean something like that up, too. That's why a lot of times you'll see crews out there from the electric company trying to keep trees trimmed back and that sort of thing. Of course, it's for thunderstorms in case trees get blown down or branches come down, but it's also for things like this. If they can keep them away from the trees ahead of time, that helps us out. Here's sleet, and if you listen closely, I've got the sound back on that computer, but you can hear as these little sleet pellets hit the hood of this car. I'll stop talking for a second. And that's probably the best way to know or to be able to pinpoint what's sleet, what's freezing rain, is just listen for it. A lot of times when this happens, even during a winter storm, you'll hear it on your window inside your house. So you'll know that it's not snow, it's not freezing rain, but it's actually sleet. And again, that's little ice pellets that have melted from the cloud and then refrozen while they're falling through the air. The other one here, more sleet, you can see kind of piling up now, and sometimes you get a lot of sleet too. You end up with a couple of inches of it. It's really heavy, and it can be a really big pain to shovel and to clean up. And then one of the other ones that's probably one of the coolest, I feel like I've seen this more and more recently, maybe I'm just looking for it, is what we call grapple. And that kind of looks more like Dippin' Dots, is probably the best way to think of it. It is, at its core, a snowflake. But what happens is as it's falling through the cloud or falling down through the air, what we call supercooled water droplets. All that means is little teeny tiny water droplets that are actually below freezing, but they haven't been able to turn into ice. They're out there in the clouds and sometimes just below the clouds, and what will happen is they'll actually kind of attach onto our little snowflake, and so many of them do that we end up with these little kind of fluffy, almost snowballs. Now this picture is really zoomed in, but if you ever see this, you'll see you can kind of scoop up a handful of it. It really does. It really looks more like Dippin' Dots ice cream than actual snowflakes. So that one we call grapple. It's more of a snow, I would say, than any of the other ones. So when we talk about forecasting snow, for us and for everybody at home, one of the tricky parts is basically, it's not that complicated ultimately. You need cold air, cold weather, and moisture to come together at the same time. The tricky part here is that a lot of times computer models that we use to forecast, and a lot of times us as meteorologists, we want the snow to happen. We want to see big weather and exciting weather. So a lot of times we kind of want this to happen more often or farther south than it really will. Here's an example. This would be a wintertime setup where we get high pressure, cold air coming in out of Canada, and it might dip all the way down into Georgia, into Florida, but then that's not enough. Of course, we actually need the moisture to show up as well. So that might be a storm system coming in out of the south. So as that storm system comes in from the south, it's actually going to bring some of its own warm air with it. So that's where it gets a little bit complicated. Warm air and moisture riding in at the same time as all this cold air is up here waiting for it. And the big question mark is basically, where does it stay cold enough while the moisture actually shows up. So we end up with this low pressure system that we try to track and figure out where temperatures are 32 degrees. But not just 32 degrees in Columbia at our houses, we need to know if it's 32 degrees all the way up into the clouds. So that's where it gets to be more complicated, and that's where things can go wrong in a winter weather forecast. But that's the basis of it. Really just need the cold and the moisture to show up at the same time. Nothing worse than just a really cold rain during the winter, and we see plenty of that in the Carolinas. And that is basically just the moisture showed up and temperatures might have gotten up to 34, 35 degrees. So everything that falls out of the cloud melts, and then you're just soaking wet and really cold. I guess that's better than having an ice storm, but still just not a very fun day. Then what can happen if that low sets up with the cold weather? This is the kind of weather maker that we end up with. Typically our biggest snows along the East Coast. And this can be shifted down farther to the south, and what we call this is a nor'easter. It's really just a coastal storm system. And what that does is send in all of this air. Remember, we have low pressure, we get counterclockwise flow around it, so going in this direction. The reason it's called a nor'easter is the wind blows in from the northeast back onto shore and onto land. That brings in colder air with it, diving in out of the north and northeast. And meanwhile, we've got all this moisture to work with here from the ocean, from the Atlantic Ocean. So we get the cold air moving in. At the same time, the storm system itself is throwing in more moisture from the ocean. And that's where we can end up with some really big snow totals. When you think about the big blizzards, 2016 around DC, I know I grew up near Baltimore. 1996 was one of the earliest ones I remember. It's always a setup like this where you get those big snow totals, maybe 15, sometimes 30 inches of snow. And it's just because that storm will stay relatively in that same place. And again, this can be farther down to the south. We can have the same sort of setup closer to South Carolina and North Carolina, but just a little bit more typical farther to the north. So talk about winter precipitation again here real quick. This is a little bit in depth, but it's the same water cycle. Evaporation, condensation makes our cloud, and then this time our precipitation, of course, is going to be snow. And what's happening up in that cloud? It's that same deal. We have all this water vapor in there. We can't see it. It's our water that's floating around as a gas. What happens with a snowflake is we get one really cold drop of water that will freeze. Maybe it freezes onto a piece of dust or a piece of pollen, and then that one little tiny drop, all of this water vapor basically gets sucked into it, and it's going to go right from a gas to ice. That's the big difference when we talk about snowflakes and clouds. Instead of making raindrops where all that water vapor turns into water and we get a bigger and bigger drop, this time we're getting a bigger and bigger snowflake. All of that water vapor, that gas, basically just turns right into ice, and that's how we end up with our snowflake. So it continues to grow as water vapor goes right from a gas to a solid, and in this case, of course, our solid water is what we call ice. There's all sorts of different types of snowflakes. Then what we can see here is these different shapes. I don't know how well you can see it, Brett, but we end up with what we call plates. We can have needles. I've not seen too many of those, but typically this is more so what we're used to, or maybe when you guys cut out a snowflake out of paper, that's the kind of thing that it looks like. A plate with dendrites, thin plates, solid plates, columns, and it all depends on how much moisture is in the cloud, where these are made, and how cold it is. What's the temperature in that cloud as well? Those two things are the two big ingredients. But remember, all the way down from the cloud as the snowflake floats down to the ground, it can change, it can add in more ice, maybe some of it evaporates a little bit. So your snowflake is always growing and always changing. And that's why you might have heard the saying that no two snowflakes are the same. And while many may look very similar, it'd be pretty much impossible, at least on a molecular level, that you'd have two snowflakes that are exactly the same. And that's where that comes from. You'll get a lot basically from the same snowstorm that might look very similar. But if you can look really close at them, it's neat. If you've got like dark gloves and they're cold and you collect a few on there, you can really see these individual shapes. So it's pretty neat to do that. Here's a couple zoomed in views. That freezing rain is not supposed to be there. These are of course snowflakes. But you have a plate here with some of these growing on it. That's pretty much a typical, I think, what we think of a snowflake. That one down there, a few more of those like that. But again, they grow like this as that water vapor basically attaches onto that initial little tiny piece of ice, and they just continue to grow in these branches. To get a little bit more scientific, the reason they grow like this with the hexagons, the 6 sides, and that's just because of the way a water molecule is built. They all combine with 6 molecules together to make a small hexagon, and it just continues to grow in that same pattern. So you can make your own ice as well. Little bit on a blizzard, real quick. This is a term that kind of gets thrown around. Sometimes we get a lot of snow, but blizzards are actually all about wind and visibility. That's what really makes something a blizzard. You need winds over 35 miles an hour, then you need some snow. Maybe it's not even falling snow. Sometimes it can just be snow that's already on the ground, blowing all around, and then visibility has to be down to about 1/4 of a mile. It has to go on like that for 3 hours. So hear things called blizzards a lot of time, but maybe not necessarily meeting this criteria. When you have a blizzard warning in your area, that's much more so an issue of dealing with some really powerful winds and dealing with not being able to see very well. I think that might be, oh, this is my last one. And the reason that I wanted to do this topic today is because we do have some really cold weather working its way into the Northeast. And it's going to get cold down into Columbia as well, but this is for this weekend, and this is just one model. It probably will not play out like this, but I just want to show you the cold air is moving in, and there's a little bit of moisture as well, and some computer models have snow showing up. Scranton, Pennsylvania, maybe ending up with a few inches, even to DC showing up there with some snow. Now again, I don't think you're going to wake up to snow on Sunday morning, but just to kind of point out, here we are May, to give you an idea of how rare of an event this is. Let me do one thing, Brett. I'm just going to see if I can slide the map, because, let's see, I just forgot to save, whoops, nope, not happening. Save my view for you, but we do actually have some of that snow that's actually going to be down here into maybe Asheville as well. Some of the highest mountains could see a few flakes as we go Friday night and into Saturday. So, and hey, it might be the beginning of May, but that is something that we are talking about. All right, let's make a couple different things here. We're going to start with our snowstorm in, you can use a jar. I like this vase, so I'm going to try and use this again. What you need, not too much, but best thing you could do would have some white washable paint. We're going to see how this goes, because I unfortunately could not find white washable paint. So I got basically, what's the word I'm looking for? Whiteout. So I'm not so sure how well it's going to work, but if you do have washable white paint, do you have washable white paint at home? Should I have asked you?
I might.
You're going to take a little bit of that, and I'm going to put it into the bottom of my
Washable
vase.
meaning like not purple.
Like Crayola, yeah.
Oh, okay.
Basically, you want something that's not oil-based, and I'm afraid that this might be. So all we're trying to make here is a little bit of a white water mixture at the bottom of this. So we'll see. You can see here if you look closely. Unfortunately, mine is not going to be perfect because, it's clearly oil-based, and that's why the water and the paint are not coming together. This might backfire on us, guys. So you're better off, of course, with a washable white paint. What you're going to do here, make sure you've got enough water in there. We're going to get ours up above where I colored it up. Then you're just going to take some baby oil, or like last week we used mineral oil, and you're going to use that to fill up about 2/3 of the way. I'm starting to question. You guys are going to have to try this at home and let me know how well it goes, because I'm afraid that our mixture is not coming together quite the way I want it.
It kind of looks like snow.
Yeah, kind of. But we'll see. Once we drop in the last ingredient that you need is like a Pepsid, or I guess you could use maybe an emergency tablet. You just want one of those tablets that's going to fizz. I don't know that I would use, maybe not your emergency these days, probably better off with something like a Pepsid. But basically, what should have happened, and I apologize, I wish I had the right ingredients for this one. Your baby oil would float on top. You'd have your white, watery paint mixture in the bottom, and then, this is a bummer, I'm gonna have to find some paint and try this again. My trusty Dollar General did not have the white. So then you just drop in your Pepsid, and what that's gonna do ultimately is start to bubble this up. And if we could see better, man, I'm really kind of disappointed. If we could see a little bit better, you'd end up with basically these white blobs popping up. So this is going to be one. I'm going to have to try this again later. My apologies on that. Our whiteout combination with baby oil did not really work very well. But ultimately, you can get a nice looking little snowstorm in here. You see maybe a little bit. Yeah, that's not quite... you might get the idea. We'll see if it settles, it'll work a little bit better. Here's one that I did get a chance to actually try, and one other thing, if you want to get a little, we'll see, maybe that'll make a difference. Put some glitter in there too, and you end up with just an even more exciting snowstorm.
It's just a pretty snowstorm.
Yeah, there you go. Man, well, this is, I guess, more of a blizzard. We talked about low visibility. That's certainly the case inside this thing. You see him floating around a little bit. That's a shame. I'll have to find some white paint, guys. We'll try that one again later. If I get a better video, I'll post it. The last one here, we're going to make our own snow. And of course, this won't feel exactly like snow, but you'll be able to get the same idea. And what we use is baking soda. And you can do this one of two ways. I tried both. And unfortunately, the one using conditioner actually does work quite a bit better. But your ratio is going to be about 5 to 1. So when I say that, I mean 5 parts of baking soda to 1 part conditioner. So because I happen to have quite a bit of the baking soda around, I'm going to use full cups. So go 1, 2, 3.
You just had a bag of baking soda?
So it's for the pool. So so I've got 5 of those, and then we're going to take about a full cup. So that's what I mean when I say 5 to 1 of this. Now, in a perfect world, I would have had white conditioner, so our snow is going to be a little bit bluer than it should be. But it should smell nice at least. And then just put that in there. And then this is where you get to have a little bit of fun with it. And you're just going to kind of fold it all together. And now it starts to come together into a really nice kind of feeling like snow. And it actually has a nice, it ends up kind of cold as well. But this is just this is definitely an outside project, so you might have to wait until the weather gets a little bit warmer depending on where you live. And if it's not quite coming together how you want it to, if you expect it to be a little bit more packable, if you want your snow to work a little bit better, you can add in just a little bit of water. And really, I don't mean much, like maybe a teaspoon or a tablespoon at a time. And then you end up with snow that is a lot easier to play with. So, it's not perfect, it's not quite the same, but hey, considering it's May and most of us are not actually going to see any snow come down this weekend, just kind of something fun to do with the kids. Definitely, again, more of an outside project, but you can make nice little, still pretty packable. You can make little snowballs with it, and you can mess with the consistency a little bit. If you don't like the way it's working, put in a little bit more conditioner. I think a little bit of water goes a long way. Of course, I dumped all my water in that other thing. But just kind of something fun to do. And really, you don't have to, you can use any sort of baking soda. You can do this on a much smaller scale. You could do 1 cup of baking soda and then just about 1/5 of a cup. There you go, a little bit of water. So now it should start to get a little bit more packable as we work that in there. But again, just something fun to do. Not really any science here behind this one, just a chance to kind of make your own snow and play with it at home. The last thing you can do, and I did not bring any with me, but if you've ever made a volcano at home, or maybe your teacher has made a volcano with baking soda and vinegar, you can make a few snowballs, maybe make a snowman out of this, and then if you do have any vinegar, especially if you put it in like a spray bottle, you could spray your little baking soda snowman with some vinegar and see what happens. You should get pretty fizzy pretty quickly. But just something, again, some nice snowballs. I think that water really helped bring it together. And it does smell good. We call this waterfall mist. But that's about it, guys. Thank you so much for tuning in. Hopefully you can do something like this. Again, this is going to be a little bit on the messy side, so maybe something to do out on the deck or on the patio, or in, I don't know if your lawn would appreciate all the baking soda, so maybe not in the grass. But yeah, really appreciate it. Thanks for tuning in. If you guys have any questions, please let me know, and I will be sure to answer those in the comments. Have a great afternoon, everybody.